Uh, Good morning. As I explained in the previous video, the bridge rectifier. So in this video, I'm going to explain how to obtain average or DC current and voltage for the rectifiers. So as I explained in the previous video, the average current and average voltage of a rectifier. So in this portfolio rectifier, observe this is the DC corresponding DC output signal. Again, same formula, the basic formula, the average value is equal to area under the curve over the full cycle divided by time period. So again, integration 0 to pi I dt d theta pi to 2 pi I into d theta. And from the diagram, so in both the opposite half cycle, I mean from 0 to pi as well as pi to 2 pi, the same curve is there. So by definite integral property, it can be written as 2 times 0 to pi. So integration 0 to pi I d theta into 2 times. So 1 divided by 2 pi is outside the uh, integration. And again substitute I value. Okay. So this 2 get cancelled. So it becomes 1 over pi Im sin theta into d theta. Then integrate. So Im is constant outside the integration. Im by pi. Integration of sine is minus cos theta 0 to pi. Again substitute, apply the limits cos phi minus cos 0. This sign is outside. So cos pi is minus 1, cos 0 is 1. So it becomes minus into minus plus 2 Im by pi. So again 2 by pi value is 0.636 into Im, or it can be written as 66.6% of Im. So IDC is equal to 66.6% of maximum current. Similarly, voltage, as you know, VDC is equal to IDC into RL. So substitute IDC, that is just we obtain 2 Im by pi into RL. So substitute Im value, again divide numerator and denominator by RL. So it becomes 2 Vm by Rf plus Rs divided by RL plus 1. Again we approximate this to 0 by assuming RL is very larger than Rf plus Rs. It becomes approximately equal to 0. So it is equal to 2 Vm by pi. So again 2 by pi is 0.636 into Vm, or it is 66%, 63.6% of Vm. This is VDC. Okay. Now DC or average value. It is average value. Now we'll see root mean square value of load current and voltage. So root mean square means it is an effective value. Effective value of output is called as RMS value. RMS value. Root means square value. So how do you obtain this? For half wave rectifier, first we'll consider for half wave rectifier. So it means RMS value of the load current. As I said, so first we should consider square value. So in the previous, when we obtain a DCR average, you are not squared. So here we consider squared value. That is current during the first half of the cycle, that is 0 to pi, and current during the pi to 2 pi squared current. So to get a mean value, this divided by the period. This divided by the period, that is 2 pi. 2 pi. So root mean square means apply root to this. So this is IRMS. Square root of integration 0 to pi I square d theta plus pi to 2 pi I square d theta divided by 2 pi. As you know, during the pi to 2 pi current is 0. So it reduces to substitute Im. Okay. And second term is 0 because current during the pi to 2 pi is 0. So here Im square sin square theta into d theta. Okay. So again we know sin square theta is equal to 1 minus cos 2 theta by 2. Substitute this. You take Im square constant outside the integration. Okay. 1 minus cos 2 theta by 2. Okay. So further it can be written as you can take 1 by 2 outside the integration. So integration 1 d theta minus integration 0 to pi cos 2 theta. So again further this can be written as im square by 4 pi. Okay. Integration of 1 is theta 0 to pi minus integration of cos 2 theta is sin 2 theta by 2. Integrate limits 0 to pi. Apply the limits. It becomes uh, pi minus 0, because for sine wave, this is the sine wave, no, green color sine wave, no. So upper limit, if I apply pi, it becomes sine 2 pi. So sine 2 pi value is 0, that is 260. Sine 2 pi value is 0, and the lower limit sine 0. Sine 0 is also 0. So the second term is 0. So only first term pi minus 0. So again pi get cancelled, pi get cancelled, it becomes, and you can take apply root square root. So it can be im square divided by 2 square. Okay. So it is im by 2, im by 2 if you apply root. So that is equal to 50% or 50% or 0.5 times im. Okay. So 0.5 into im is the root mean square value of your rectifier. Similarly, we will obtain root mean square value of voltage VRMS. So again, VRMS is equal to IRMS into RL. Just we obtain IRMS is equal to IM by 2. Substitute that into RL. Substitute IM is equal to VM by RF plus RS plus RL. So it is equal to VM into RL divided 2 times RFs plus RS plus RL. Again, divide both numerator and denominator by RL. It becomes this one. Again, this can be approximated to a 0. So again it becomes, this is 0, it becomes Vm by 2. So that is 0.5 times Vm is a VRMS for off-wave rectifier, for off-wave rectifier, right? And for full wave rectifier, same thing, same rule, same formula, and it is by definite integral property 2 times 0 to pi. Again 2 get cancelled, so 1 divided by pi into, substitute I value, that is im sin theta, im square sin square theta. Same procedure, im is outside the integration since it is constant, and the sin square theta is 1 minus cos 2 theta by 2. So again 1 over 2 is outside the integration, and apply integration to individual terms, that is 1 minus cos 2 theta over the period, over the integration limits 0 to pi. Then this is sin 2 theta by 2. Apply the limits. Sin 2 pi minus sin 0, it is a 0. So remaining is im square by 2. So this is im by root 2. Okay, im by root 2, or else 1 by root 2 is 0.707 im, or in percentage we can say 70.57% of im is the IRMS value of full wave rectifier. Similarly, VRMS is equal to IRMS into RL. Substitute IM is equal to, IRMS is equal to IM by root 2, and substitute IM value, okay, and divide both numerator and denominator by RL, and then later we approximate this value to 0, so it reduces to Vm by root 2. So that is 0.707 Vm, or 70.7% of Vm is the VRMS value. Clear now? Fine. Now we'll see efficiency of rectification. So it is defined as the ratio of DC power delivered to the load by AC input power from the transformer secondary. That means PDC divided by PAC. So as you know, P is equal to I square, P is equal to V into I, P is equal to V into I, or V is equal to I by R, no? So V is equal to I R, no? So I square R, or I is equal to V by R, so V square by R, V square by R. So here PDC is equal to IDC square by IDC square into RL. So we derive now I square R. So PDC is equal to I square IDC square into RL, and PAC is equal to, for AC we consider RMS value. So IRMS square into R means uh, RF plus RS plus RL. See here, for DC we consider only RL. For AC we consider resistance offered by diode, secondary transformer, as well as load resistors. And substitute this into the efficiency equation. Eta is equal to IDC square into RL divided by IRMS square into RF plus RS plus RL. Again, divide numerator and denominator by RL, so it reduces to, okay, again we approximate this to 0, so it becomes IDC square by RIRMS square. This is the general expression of efficiency. Okay, so this is expression of efficiency. Now we'll consider half wave rectifier. For half wave rectifier, we know IDC is equal to Im by pi, IRMS is equal to Im by 2. Substitute these into expression efficiency. Okay, and yeah, it reduces to this form, and we know A by B divided by C by D is equal to A by B into D by C. So it can be reduced to Im square by pi square into 4 by Im square. Im square get cancelled. It becomes 4 by pi square. 4 by pi square. Or we can say it is 0.406 or 40.6%. It is efficiency of half wave rectifier. Similarly, consider full wave rectifier. For full wave rectifier, IDC is equal to 2 Am by pi and IRMS is equal to Im by root 2. Substitute this into the efficiency equation and they will reduce. So the numerator becomes 4 Im square by pi square and denominator is Im square by root 2. Can further it can be simplified. Here Im square get cancelled. Okay, it becomes 8 by pi square, or it is equal to 0.812. That means 81.2%. So if you compare with the half wave rectifier, efficiency is double. Efficiency is increased. Clear? Na? So this is what rectification of full wave rectifier and half wave rectifier. I'll continue in the next video. Thank you.